Welcome, everyone. So nice to kick off our first panel. We are going to be talking about building with responsibility and intentionality, a topic that seems to be top of mind these days, especially this year. So to introduce our first speaker, we have Pelonomi Moiloa. She has flown in from Johannesburg to talk to us. She's the CEO and co-founder of Lelapa AI, an entity dedicated to advancing AI research and products by Africans for Africans. Her training in biomedical and electrical engineering complements her 8 years in the data science domain, especially within the finance industry's machine learning applications. She's a mentor and trustee for the Ruth First Memorial Trust Scholarship Program and co-directs the Ungovernable NPC, overseeing Code Kamoso, a coding academy for girl teens, and a community vegetable and medicine garden. So with that, I want to welcome Pelonomi. Fun fact about her, she nearly got arrested for growing vegetables. You'll have to find out why. Welcome, Pelonomi.
Hello, everybody. No, it really was vegetables. Apple bombs like vegetables. No, I mean like butternut and pumpkin and cabbage and stuff. Hi, everyone. Thank you so much for having me. I hope that my brain will be able to keep up with the pace of the MIT alumni. Clearly, I'm half of the room that isn't that smart, and jet lag is not going to help. But as has been mentioned, I am the CEO of a startup from Johannesburg, South Africa. And we are focused on bringing about an observable uptick in the quality of life of Africans. And the way that we have started to do this is with our socially grounded Africa-centric AI research and product lab. And we are specifically focused on Southern African indigenous languages. So although there has been a lot of incredible progress in the language space and language AI, particularly with LLMs and ChatGPT more recently, Southern Africa is one of the places that has been left out of that conversation and left out of the benefits of what has come out of that process. But Southern Africa isn't alone. The majority world makes up 85% of the world's population, and ChatGPT doesn't work on those languages. And so really what I'm here to talk to you about today, and we don't have much time, so I'm going to keep it short and sweet and make sure that you leave with something that I think is important. But basically, I would like to speak to you a bit more around data. So I think there's a common misconception that more data, bigger models is the way that we need to go. There's a lot of conversation around generalized AI, the singularity, and creating this one machine to rule them all. But from our experience, driven out of our context being on the African continent, you know, I mean, on the African continent, I'm sure you're all aware that there's limitations to access certain things that are required to build technology, things like electricity or mobile bandwidth or internet connection and things like that, which means that there are severe challenges on the continent for us to be able to compete in the same way that the rest of the world competes. But what that means is that we are forced to just be smart. Smart about how we gather our data, how we build our models so that we're able to solve solutions in a similar way. And what that has really brought into our consciousness is that even though that there is this trope around more data, bigger models, what we find for us specifically is more data, more problems. So you can see here, this is a paper that is part of the African research community. And the training data that has been fed into many of the language models that we are having to deal with and that are imposed on us for products and services just do not have the right things inside them. This is an example of some of the training data in the Oscar data set, where 6% of the data around indigenous languages is not a language. So basically, the data that's going into being training that model is not actually data. So on the left, that says Northern Frisian. On the right, we have Somali. That is not what Somali looks like. That is not Somali language. So what we're realizing here is that under the hood of these supposedly really advanced scientific processes is a severe lack of scientific process that is very much driven by this bigger is better narrative. And, you know, I think this bigger, better narrative has been posed as the answer to life, and no, it is not the answer to life, and neither is the number 42. What the answer really is this approach of data efficiency. And data efficiency is important to us for many ways that I will speak about in the next session, but I would like to talk a little bit more about the ways in which non-data efficiency is not so useful. So earlier we had the presentation around climate change, you know, and understanding that the bigger the models get, the more data required to train them. Even if they don't work as well because they're trained on gibberish, there are dire consequences that result in things like exacerbating climate change because of the amount of materials and resources required to do that. It also results in genuine harm and biases. If you are going to sample from a population and your approach is just to get more data from the same population, it just means that you're sampling the same amount of bias from the same biased population. So yeah, there are issues around this, and our answer is data efficiency, a process that we've learned ourselves at Lelapa AI in this constrained environment of resource access. We're just able to do the same kind of thing with less data and with smaller models. And the reason why we believe in data efficiency is for two reasons. That data efficiency helps to ground you within your context and domain of the technology that you're developing. And it also means that you have to focus very much on quantity over on quality over the quantity of your data. Why is this important? Well, for us, context and domain means that you're able to embed inherent knowledge that people have into the models that you have. So you're not assuming that they then need to learn all of the embeddings and inference from the data that you give to it. You, as a human, are able to collaborate with the machine on on a collaborative level in order to derive the information that it needs to be able to perform well within context. With a quality versus quantity issue, you're just able to do so much more if you have high quality data rather than the gibberish that I showed you earlier. And for us, data efficiency is synonymous with data intentionality. So this is the responsibility and intentionality session, so this is why we brought it in. And just to close, for us, intentionality is quite an important process because intentionality is like the best metric score of both precision and accuracy. Because with your precision, with your context-driven and domain-driven data collection and assurance, you're making sure that you are targeting the right thing. And with accuracy, you're making sure, with accuracy, you're targeting the right thing. With precision, you're making sure that you're hitting the same place at the same time all the time. So yeah, that's just my brief introduction. I'm going to keep it nice and short and sweet because I would prefer to have a chat with the people who join me on stage later. Yeah, and that's it for me. Thank you so much.
So I'd like to introduce our next speaker. Jan Leike is the alignment team lead for OpenAI. He co-leads the super alignment team at OpenAI, where he's been involved in the development of InstructGPT, ChatGPT, and the alignment of GPT-4. He developed OpenAI's approach to alignment research and co-authors the super alignment team's research roadmap. Prior to OpenAI, he was an alignment researcher at DeepMind, where he prototyped reinforcement learning from human feedback. He holds a PhD in reinforcement learning theory from the Australian National University. In 2023, Time magazine listed him as one of the 100 most influential people in AI. So we're very happy to have him here. And fun fact about him, he would like everyone to consume more edible flowers. We seem to have a theme on nature and gardening with our panelists. So with that, welcome Jan.
Yeah, thanks a lot for having me. just to clarify, you don't have to eat edible flowers if you don't want to. I just think they're great, and we should, should be an option. Yeah, I want to talk to you about super alignment, which is a team I co-lead at OpenAI together with Ilya Subscaver, and what we've been up to and what we're planning to do. So we believe superintelligence could arrive this decade. Let's hold on for a moment and think back to GPT-1. GPT-1 was a model that would struggle to string together a coherent sentence. And if you contrast that with GPT-4, a model that now assists millions of people every day in their actual jobs, that's a pretty big difference. And now remember, there's only 4 years between GPT-1 and GPT-4. Progress has been quite fast, in my opinion, and there's no reason to think that it's slowing down. So I can only imagine what the next 6 years will have in stock for us. The next thing is that nobody actually knows how to align superintelligence. Nobody knows how to make it follow human intent, enable human flourishing, or stop it from going rogue and taking over. So this is a very complex problem that has many facets. And the aspect that we are focusing on is what we believe to be a core technical problem of this challenge, which is how do we supervise AI systems that are much smarter than humans? In other words, if you have very capable models, they will do very complex tasks, and we will struggle to know whether they're doing it in accordance with our intent or how we meant them to be done. So for example, imagine you have GPT-7 and you ask it to write 1 million lines of code. And the model writes the code, and now how do you know that this is actually the code that you wanted? Right? There's no way that you're going to find all the bugs in 1 million lines of code. And in fact, humans are pretty bad at finding bugs in code. That's why there's so much shitty software in the world. And so because of this, the current state-of-the-art alignment techniques, such as reinforcement learning from human feedback, will not scale to these kind of models because they fundamentally assume that humans understand what AI systems are doing and thus can give feedback effectively on a proposed answer. So how are we going to solve this problem? This is our plan. I have slightly abbreviated it because the full one didn't fit on the slides. So first, we want to figure out how to make the first superhuman AI systems sufficiently aligned, in particular, on the task of doing alignment research. And if we can succeed at that, we can then, as a second step, use what is technically known as a metric fuck ton of compute to run the automated alignment researcher a lot and have it figure out how to align its successor systems and ultimately superintelligence. So to enable the second step, OpenAI has committed 20% of the compute they secured by July 2023 towards this effort. And so we don't have to worry about not having enough compute to do this. But how are we going to do the first step? This is what I want to outline a little bit more today. This is very much work in progress, but it should give you a glimpse on how we are thinking about approaching this problem. And on a high level, I think we'll need 2 classes of techniques. The first one is techniques that allow us to train AI systems to be more aligned. And the second one is what I would call validation techniques that help us figure out whether we actually did a good job. So the first technique we use to make our AI systems more aligned is what I would call AI-assisted human feedback. So this is quite a natural continuation of RLHF, reinforcement learning from human feedback, where we train AI systems to assist human evaluation. So if you imagine you have your 1 million lines of code, and you'll struggle to find the bugs in that code. But if you have an assistant that points out bugs to you, it will be so much easier to check that these are in fact bugs and they should be fixed. And so if we can train a good assistant model to find bugs, then it will enable humans to much more effectively supervise AI systems on hard tasks like these. And so our goal today is to train versions of GPT-4 that will point out all the bugs in code that they are aware of. And the difficulty here lies in figuring out what bugs they're aware of. The next technique for improving the alignment of our system that we're working on is easy-to-herd generalization. So the idea here is we want to supervise AI systems in easy settings where we have high confidence in our supervision. So let's say we could supervise bugs in 10 lines of code. And then we want to use the magic of deep learning to make them generalize correctly to difficult settings where we can't supervise effectively anymore. And so, in other words, we want to latch on to the underlying concepts the model has learned of what does it mean for code to be correct, or what does it mean for an answer to be truthful, and then use this concept in the settings that are actually very difficult for us to know whether a code is correct or whether an answer is true. And so what we're doing today here is we're using small language models to supervise larger language models as an analog for using humans to supervise AI systems that are smarter than us, and see whether we can bring about these generalization properties that we are looking for. Okay, so, and now for validation, how do we know that we are actually making our system sufficiently aligned? One technique that we are hoping to leverage is automated interpretability. So the idea here is, even if you think about systems like GPT-3 that already have hundreds of billions of parameters, there's no way that humans will be able to look at each of them, especially if you have small teams. But if we can train AI systems to follow the interpretability workflow that humans would use, then we can radically scale this workflow to models of huge sizes. And so what we've been doing today is using GPT-4 to automatically explain neurons in GPT-2. And this is not itself restricted to GPT-2. You can explain neurons in any model. The major problem is just it doesn't really work that well yet. And so we're trying to improve it. And then lastly, we want to adversarially test that what we're doing is actually good by deliberately training deceptively aligned models. That means models that pretend to be aligned but actually have ulterior hidden motives. And then we want to see whether we could reliably identify these models as opposed to what we believe are actually aligned models. And so what we're doing today is training a version of ChatGPT that has a hidden agenda or a misaligned personality, and then seeing whether what we can learn studying empirically. And when you're doing this kind of work, you have to be extremely careful that you're not accidentally bringing about the whole thing that you're trying to prevent, obviously. So, yeah, we're going to need a better cage than this one. So overall, our goal is to figure out the problem of how to align superintelligence in the next 3 years and 8 months. This is a very ambitious goal, and we are not guaranteed to succeed at this effort. But we think fundamentally that this is a very solvable problem, and then with focus and dedicated effort, we can solve it. So here's what you can do. So first of all, be engaged and informed. Listen to the AI experts. Don't listen to the pundits. And then second, hold AI developers accountable. Make sure they actually keep the promises they make and use AI for the best of the world and not for selfish gains. And then thirdly, if you're interested in working on alignment research yourself, consider joining us or consider joining alignment teams at other AI labs. And that's it. I'm looking forward to chatting to you all about this.
Thanks, Jan. So I'm going to introduce our third speaker today. We have Rania Khalaf here. She is the Chief Information and Data Officer for Inari. She is the Chief Information Data Officer at Cambridge-based Inari, the seed design company using AI-powered predictive design and multiplex gene editing to help build a more sustainable global food system. So we do have food across all of our three speakers here. Rania leads the company's engineering, data, AI, and IT capabilities at the foundation of Inari's cutting-edge technology platform. She has an extensive multi-decade track record of leading and delivering award-winning innovation in cloud-native AI platforms, human-centered AI, serverless computing, and web services, including as Director of AI Platforms at IBM Research. A board member of the Harari Institute for Computing at Boston University, Rania earned master's and bachelor's degrees from MIT and a PhD from the University of Stuttgart. And fun fact about her, she shared that in her youth, what she did for fun was she participated in show water skiing, which, I mean, you have to ask her how she actually did that. With that, welcome Rania.
All right, thank you, Mitali, and I'm so excited to be here. Thanks for joining us today. So let's take it away. We heard a lot today about AI and AI itself and how it can be used, and now we're going to jump more into really looking at a particular solution space of how we can use these developments into creating a more sustainable global food system. If we look at what's happening in the world today, the population is growing at a crazy and increasing rate. This looks nearly like the AI adoption curve and innovation increase in AI, but it's about the human population that we need to be able to feed. And we also saw from the presentations before me today that climate change is real, it's happening faster than any of us would like. And if we look at the food system overall, it's really an immense amount of resources that it is consuming, both in amount of fresh water, and the amount of land needed, and in the amount of greenhouse gas emissions that it produces. These numbers are, I know this is an MIT crowd, so this is about the whole food production system. So multiple variables are taken into account here, but it's really crazy for me to look at these numbers, and this is today, so if we look back at that curve, it's really a very interesting to think about this and get super worried, like you guys. I don't have the nice video of animation of where this goes, but you can really imagine. The yield increase in plants historically has been about 1% a year. That's how much more food comes out of these plants, food and feed for animals. And it's just not going to be enough to sustain it. What we really need is a step change in how we are growing the food that we do so that we can use less resources, less land, and then create more food out of it. So at Inari, when it was founded by Flagship Pioneering, the question was, what if? What if we could use the intersection of biological and data sciences to really unlock the full potential of seeds and create this step change that can really make a difference to climate and food. And I'm really excited that we are really nearly there today, getting into products starting to appear. We really see some increases. And one surprising thing for me coming from the pure tech world was the timelines here. So as they mentioned, I was at IBM Research AI, and I got the call from Inari. It was the middle of COVID, and it was kind of hard to say no, because I was there, and I loved my work in IBM. I loved working on core AI. I loved helping banks and insurance get better. But, someone said, hey, food and climate change, what do you think? And, those two things mean a lot to me. I grew up in the Middle East where water was a really big issue, and Climate, we all know and hear a lot about what's coming. So it was an opportunity to take everything I've known and learned and apply it to a new space. I have no background in biotech and no background in architecture, so it was quite the leap. But looking at a company that was doing something at the intersection of cutting-edge advances with CRISPR-Cas in the gene editing space and the opportunities in data and artificial intelligence to solve such an important problem, it tickled all the boxes for me, right? Solve a really hard problem where no one knows the answer, be at the intersection of disciplines that are all going through a fantastic technology shift at the same time, and be in a place that is really set up to be able to bring these advantages together reliably and in ways that can really make a difference. We heard today from Mark, I have my napkin notes here, in true geek sense. We heard today from Mark that one of the future items is about AI native science. I strongly agree with that, and that is really what we are doing at Inari. And it really takes, we heard about bilinguals and multidisciplinary teams, and this is really, because these technologies are evolving so quickly at the same time, it's really important that we can interleave them together. We need to cook together and pressure cook these disciplines so that we can really unlock this problem and make advances in it. It took me about 3 to 6 months maybe, and that's about how long it takes someone coming new to Inari from all these disciplines to be able to understand enough and standardize the language, right? So I say architecture, I'm thinking of databases and servers, and then I realized that the agronomist or the breeder next to me is thinking about the leaf angle and the plant height. I say vector, I'm thinking of a vector, and they are thinking of a bacteria or some biological organism, right? So it is really, I love that term bilingual, and here we are trilingual because we also have agronomy, we have breeders, that we need to really work together to solve this problem. So our approach is we're a seed design company, so we're using multiplex gene editing, so we have created novel technology that can edit multiple places in the genome at the same time to either knock off, fine-tune, or adjust different parts of the plant genetics. The problem is there are millions of places where you can do that, and plant genomes are super complex. They're much more complex than the human genome. And we focus on large row crops, so corn, wheat, and soy. And to optimize that, you look at yield. And yield is a population trait that you can only see and measure in the field. It's bushel per acre. But when you look at one plant at a time, that's what you're measuring in the lab or in the greenhouses that we have. So this is where data and AI can really help, to help our scientists know where and what to edit. It takes about 10 years traditionally to take a product from idea to market in our space. So our parallel is drug discovery companies, maybe the closest parallel to those in the healthcare domains. And we're trying to we've shortened that now to about 4 to 5, and we're trying to get the numbers to be much better in the amount of water utilization, fertilizer use, and yield that these seeds can consume. So let's look at what happens, what does this mean? If you know, humans have been cultivating food for 12,000 years. And the way this has been done, it's been by crossing manually different parents, and it's really an art. So a lot of these breeders, it's really an art form. Some of these companies it's like a family company by one person who just has the really great spidey sense of knowing which parents to cross to create better progeny and create better seeds. These plants did not evolve to be better food, right? It's evolution. They're trying to be better plants. So if we need them to use, to be better for the climate and to be better for humans, then we have a super alignment problem of our own. So let's just understand what happens here. So we take these seeds, and then for corn, we get the embryo, and then we use CRISPR-Cas systems to make to fine-tune and adjust the natural genetics of these plants. Then we grow them in growth chambers, take them to the greenhouse, and ultimately take them to the field, and then take them all around the world for testing in different climates and environments to gather that data. And at the end of that pipeline, we create what's called a parent seed, and then we partner with independent seed companies that take that and can can scale up the production. It's called bulking up. So they take our bag of 100 seeds and they make 1 million seeds out of it. And they sell directly to the farmers. So you can see here a lot of issues in data and AI that crop up and where we can really help. There's how do you connect from the lab to the field to be able to track and trace the material going through? There's a lot of work on the genomic side, and we also heard a lot today from Elad and others that there's an issue with like if you want to be AI native, you need to be on AI native platforms. So we're on Databricks. We're very, we've been trying to put these foundations in place and making good progress there. But if anybody here is working in that space, we implore you to do more work on genomics data because it's really, there's a lot that can be done to make it better for that kind of data. And in agriculture, the data is sparse, and we really want more of it and people to share more of it. So we're very passionate about that because it is a data sparse problem we're trying to solve, and biology is complicated and nonlinear. So we try to apply AI in multiple stages of the process so that we can make better seeds faster and really get better at where and what should we edit with our gene editing technologies. So to wrap up, this is our approach. We have created an advanced multiplex gene editing toolbox that has very sophisticated editing capability. And now we are building the predictive design engine that can really help the scientists know how to use the editing toolbox to increase the editing efficiency and to create better seeds faster. So with that, yeah, that's my 10-minute notice. Thank you very much, and happy to talk with you more.
So before I go into, well, we have 5 minutes, so I'm going to just read out one of the first top voted questions on Slido. So the question is, what type of human values can you align superintelligence on? We have no alignment about priorities or even good versus evil between humans. And I know this probably, Jan, you talked about alignment, so it'll go to you maybe first. But I do think, both Rania and Pelonomi, you talked about how the companies that you're working for are also trying to align with what's good for humanity. So I'd love to have both of you respond as well. But Jan?
Yeah, I really like this question because I think it's a really important question. And also, I think, there's like many facets to alignment, right? And we are not focusing on all of them. But I also believe that we don't have to fundamentally answer the question of what exactly our values are in order to succeed here. And in some ways, AI can help us do this. But also, ultimately, right, this question needs to be answered by some kind of democratic process that determines what values AI aligns with. And you also want AI that aligns with you personally and your values, right? And so there's a lot of open questions here that, I would love for more people to be thinking about.
Thanks, Jan.
Yeah, I completely agree with what Jan is saying. Back to, we also heard, I think, from someone this morning saying that, start with there's so many more problems before you can get to how to align it. Is what you're aligning to so perfect? Then what are the methods that can be used? So there's a lot of invention needed that Jan's group, I believe, is working on there. I also think for us at Inari, I think a lot about the cost of being wrong, and for us, maybe if we're wrong, a plant might die, or we might waste more money in trying out an answer from these AI systems that may not work. But there are other domains where if you're human healthcare and so on, their consequences are more dire.
I can totally understand that there's different steps to get there, but it sounds absolutely wild that you would say that we don't need to decide what values to align on. It might be in 10 or 15 years, but if you have particular perspectives and views that are making that decision, it means that most of the world is not on the same page. And I think even now in our current context, there's very clear differences in principles and values in different areas of the world, and ethics are localized. So if you come up with a superintelligence that decides what's wrong and right for everybody, you're definitely going to leave people out of that conversation and definitely have dire consequences for those people.
Thank you. So we are probably almost at time, so I'm going to ask one last question. The speakers are going to be around, so you can definitely catch them and ask more questions. So related to this conversation that we're having, one of the questions in here is, how do we reconcile the debate between focusing on problems of today, like AI bias, and as Pelonomi, you mentioned, data, both efficiency and scarcity of data and access, versus longer-term concerns of AI alignment. And we know there's a lot of talk in the media and with pundits, trying to create a lot of fear. I think the folks up here are largely very optimistic about where AI can take us. But as we heard today, it's moving very fast. So how do we balance between focusing on the problems of today, but also keeping the longer-term future in mind? I'll let anyone. Does someone want to start?
I mean, I have a thought. It's not a complete thought, but I think the fact that there are different people advocating for different parts of the problem is a great place to be. I think as soon as everybody converges onto the same beliefs and same thoughts and same priorities, it's a bit of a dangerous thing. But if we have everybody who has the thing that they're fighting for, I think that's a good place to be.
Yeah, I think of it, so before this job, I used to manage a big industrial research team, and there was always this thing of how do you balance the investment in the 5 to 10 years down the line and the investment in the project that's going to, feed the team and putting things into product and getting it to customers. So I think of it like that. You need to solve the problems of the today, but you need to keep some amount of your investment in what can be for the future. And in Inari, we see this every day because we need to build the foundations from a digital standpoint, but we also need to break new innovations in the seed design space.
Yeah, I agree with this. Basically, there's a lot of problems in the world. Some of them are further out, some of them are closer. Doesn't mean we should ignore any of them, right? Like, climate change is going to be a big problem. It's not that big of a problem now, but doesn't mean that we shouldn't work on it, right? And, we have a lot of, poverty and homelessness and whatnot right now. Doesn't mean we should ignore these problems, right? These are all problems we should solve.
Great. Well, thank you to all three of you for participating in this panel. We're at time, and I think Jeff is going to tell us where we're going to go next. But thank you, Pelonomi. Thank you, Rania. Thank you, Jan.